Welcome everyone to more live open source and low level code discussions and Linux distribution maintenance. Today, to no one's surprise, kinda sorta, GCC or ffast-math considered harmful. Here as seen also by some articles, and in general I knew that to some degree. However, what I didn't quite realize is that also Ofast enables this behavior. Because so what is the thing? Fast-math, better to be renamed unsafe math, because it's doing unsafe and non-standard compliant math optimizations surrounding floating point stuff. And that's not even, oh, can you scroll? Actually, you can freaking scroll that. Wow. And the issue is we recently changed to some of the fastest Ofast optimizations when we benchmarked it. And only now I realize, so what is the problem? Of course, I kind of knew like Ofast, feeling lucky riding the Russian roulette train here. And we selectively did that based on profiling on only the very hot code paths files. And I would in general be fine with that. Also, we test that obviously, right? Kind of sort of using our own stuff here. And so we would hopefully eventually notice if some fast math stuff breaks. But what I didn't realize is that this at times, or like always, as we see here, will change the whole program's behavior, right? And that is the most dangerous stuff. So while I thought we optimize some hot code passes Ofast, and with that ffast-math also, maybe fast-math shouldn't be in Ofast, but that's another thing. So there is a very detailed article here, certainly many of also floating. What you probably also should read is what all programmers should know about floating point, because it is obviously also a rather complex affair. And so with all those at times unsafe optimizations, and even some are even not too bad, right? Because only some math can actually vectorize this stuff, because if you otherwise would adhere to all standard conformance, you would at times not be able to vectorize this stuff. And obviously we want to vectorize for all the performance on our portable devices and stuff, right? And there is a 10-year-old open source GCC bug. So because the biggest issue is all those optimizations, yes, unsafe, fast, but unsafe and stuff. That wouldn't be the worst thing if it would not be that this links in some startup file with GCC that sets here some fast-math rounding of near zero D subnormals or denormals. And that is a super dangerous thing, because what happened there is that it changes, because I thought we just optimized some hot code paths, right? That would be, sure, we need to test that and performance, but that would be sort of fine as it. But if linking that in, it's also not only the program, right? It's also shared objects, because there was also, not only did I realize this myself, but there was also recently a post on Python. I probably should, fast-math Python. Someone did a survey on fast-math stuff on Python and found that some percentage of Python modules are linked with Ofast or built with Ofast because performance. And with that, loading shared objects with this is not only altering your fast optimized code, but your whole program. So if you have one shared object, be it Lua or some FFTW or OpenGL, and that is built with fast-math for performance, your whole program is altered, because at startup it's setting as a set fast-math the rounding of subnormals, denormals towards also Wikipedia, obviously you want to read that, number is very close to zero, and that can seriously break your programs, right? And there is a GCC bug that is freaking 10 years old, right? This is like for 10 years freaking new. That is a state of not funded, underpaid, and underloved open source developers. How can such a freaking bug reported by prominent people be 10 years freaking new with sure a little bit of discussion, but not really too much to see? But with all things, so that is also not even affecting only T2, right? I mean, certainly who knows what Intel is building their clear Linux with, but in this example, they even particularly point out, obviously what I just summarized unsafe math optimizations say. And also, I also have, there are other problems in my opinion. So the doc says for unsafe math optimizations, when used at link time, it may link, also it not may link, it will link. I mean, the documentation say it may link, but actually it should say not may, but it will link in, although it might, although the only saving grace there is it may link in depending on your architecture, but for many it will always link in, like x86. So that changes the default floating point unit control word or other similar optimizations, like rounding near zero values of sub and denormals towards zero. This is, in their opinion, and my opinion, and many professionals' opinion, bad. Will cause to issues and bugs and stuff. And also they say here Red Hat, right? Somewhere it was here. Craig Smith joins in. This issue is really bad. Also 2016, right? That is 16, so 4 years or so after the bug was reported, and still 6 years later now, over 6 years later, this bug, and this should, what is my problem with it, right? Sure, super experts, but even I kind of knew that, but I can also not remember each of those peak bug details, right? There's also a limit of how much random garbage I can remember. And that this is still not like addressed in a more useful manner. And so this issue is really bad, really bad. Their potential startup changes more and more runtime behavior of downstream libraries and apps the longer the bug persists. For example, Red Hat 7 libLZMA is linked with Ofast. It also trigger CRT fast-math, because I mean, obviously Ofast is including fast-math, but there's a bigger problem with that, as I just found out live here on this channel. So corrupting the XCSR register at library load time, the bug might be specific. And this is also crazy, right? For stuff that is loading stuff dynamically, it might start up with not this behavior. So it might only exhibit this after like GL, OpenGL. Like imagine you work with Excel or some OpenOffice spread equivalent. It is working fine until you do. More people should know that. But my recurrent grief with the state of the industry is, right, everything is buggy, right? Sure, it's in maybe somewhat unsafe. Maybe it should not be, as they point out here, named fast math. Maybe it should also be named unsafe math. Also drop frames because Vodafone's failing doxes sucks. But we also should not, especially the compiler engineers, who should know all those details like 10 times more than we do here, that order of magnitude more than we know here. They should already not implement it like that, right? They are allowing everyone to shoot, everyone and their kids shoot themselves into the food. And even experts like me not realizing that instantly, and promoting unsafe behavior, implementation details and stuff. And here also, as I just said, which also triggers that corrupting that register load time bug might be specific because edit RPM spec. Also, are we the only unprofessional one-man YouTube channel doing that to the Linux distribution? No, Red Hat is intentionally not like we do this with compiler wrappers and optimizing everything in a unified way. Of course, some might argue lesser distributions hard code all of that in their APG builds, as seen the other day when we stole all those 5,000 packages of Alpine Linux. They might not have as generic and nicely transformed, unified and automatically added optimizations like T2. They might manually do that, right? And then as a distribution as a whole, you don't even know what package is added there. And then you have their one, because performance, compression library, clobbering your math precision of all your system. And for some reason, OpenGL libraries, libgl API depends on libse Linux, which depends on libLZMA. So neither OpenGL fast-math nor SE Linux, but because they depend on libZMA, every freaking SE or GL application in Red Hat, they are of at least this version, will have their math IEEE 754 semantics broken. That's terrible, yes? And this bug is open and new for 10 years and another 6 years later. Although, whatever, maybe some other person, whatever, didn't follow the spec from Ofast. Yeah, whatever. Details. The craziest thing is I just tested that here, so I diffed that here, object dumped and stuff. So I actually thought, yo, that's easy, because the documentation they said may be added with either fast-math or unsafe f-unsafe math optimizations. So I thought, yo, that's easy. Let's Ofast and no unsafe math optimizations or no fast-math. And to my surprise, that didn't remove that, right? If we this, I think, and then we diff that to fast, or we need to object dump that new to no fast-math, and then diff that fast2. So no changes, right? And this is also, according to the documentation, I would have thought if I Ofast and then no fast-math and no unsafe math optimizations, I wouldn't get this, but more, we still get this here compared to 03, that is set fast-math. So I checked what normal sane developers obviously do, right? I checked sources and look at that. They explicitly, so this is another bug in my opinion, right? In my opinion, this should be programmed. So what is the issue? The issue is that they've specified there in their headers here of some architectures that they enable this global math control register clobbering of rounding of denormals of subnormals. It is hard-coded, right? This is also not, I mean, why do I need, sure, I might be a better programmer and engineer and stuff, but why do I, in 2022, live on YouTube, realize, wait a second, why is this programmed so shitty, right? In my opinion, this should be programmed and wired to the ffast-math or f-unsafe math optimization option and not hard-coded to any Ofast, because what is the issue? I now say Ofast, but no unsafe math optimizations or no fast math optimizations, and I still freaking get it because someone in their infinite wisdom of outstanding compiler engineer, marvelous engineering, decided to freaking hardcode that on Ofast. It's like, why would you freaking do that? Why? If it should be, in my opinion, programmed so that Ofast selects the fast math option and I can still freaking disable it. But no, we can't do that, right? So if we wanted to continue to use Ofast and not have this CRT fast-math shit business here, which in our case, in our smartest optimization case, is even only selectively on some freaking files with math-heavy stuff, you still get your whole freaking binary shared object library or executable freaking linked with the CRT fast-math object nonsense. So, because it's so stupidly hard-coded, you can't even selectively disable it with Ofast. For example, to still have the Fortran optimizations for all those people who still, because it also allows stored data arrays and Fortran-specific stacked arrays, and no protect parents, and turns off semantic interposition. So that is really disappointing. I'm not, so the whole stuff, right, that this bug is 10 years new, that other people have Red Hat, sure, maybe they changed the LZMA spec, but maybe something was done in Red Hat, I'm certainly not looking that up. But the whole situation that it is implemented in such, some would say, imperfect and buggy ways, not changed for decades, not like improved on, and then even the freaking options here hard-coded in such a way that you can't selectively disable them, is really, really disappointing. So what I could do now is, what would be the solutions? The solution is I could not use Ofast, which in some cases is faster. And I would actually say some of these fast math optimizations are not even too bad for like floating point heavy stuff. Imagine we profile our Mesa library and we would want some super fast and unsafe math on some 3D gaming stuff, because who cares if that is some sub-pixel off or whatever, and vectorize this code more and so on for your AMD Zen 2 APU. And So either we don't use Ofast or we patch that here. That would be because normally I would use this with options, but obviously it doesn't work, as you see. So we could patch this freaking stuff here for that. The only question is, I wonder if I should patch it or SED it, because the problem is if we, I mean, maybe I should patch it, then I see if this changes. We could otherwise SED it, but then it's harder to see if it breaks. It's probably easier to see. That is always the pro and cons, right? You can just SED this stuff away, like when building in T2 with the sources of pre-make SED in place substitute of that away in this header. Maybe I patch it though, then I have a little bit more monitoring of whether this ever changes upstream. But that is another crazy find, right? And the crazy thing is, independently of Apple's peak bugs, where each time I tap something breaks, it is crazy that recurring reminder that the whole industry is built on such fragile and at times buggy optimizations. And this is only the peak, the tip of the iceberg, right, that we see here. And who knows how many other unsafe, broken and stuff that we only see sometimes when stuff, internal compiler errors, ICEs or otherwise people guru meditate. So to test that really, yeah, so I can't even pre-test this, right? I would otherwise kind of love. I mean, we could also use, we could manually turn on some other options there. So they have here unsafe math optimizations. I mean, the other third option would be to use O3. And there are some options like math. There is some, but that is no trapping math, associative math, and reciprocal math. Because Ofast enables this group of no math error, no unsafe math optimizations, finite math only, no rounding math, no signaling nonce. Actually, wait a second, no signaling ones. That is also a little bit tricky. So signaling nonce we would otherwise often need. Maybe I should simply not use ffast-math. Or because the issue is often dynamic languages like JavaScript, Lua and others use signaling nonce to implement boxed integers and stuff. So maybe we simply shouldn't use it. I only wonder if we, which do we have? Maybe we have fixed math. And then we take a look at the comments. But yeah, this is so much time. Also multiply this, my recurring theme here, multiply this with 1932 other Linux distributions who need to review all this stuff as well and find this. Where even did I had that? Was it not somewhere there, or do we have that there? No. Oh, where am I? Oh, wait a second. It's probably in GCC then. That probably otherwise. Yeah. So do we have fast? Yeah. So we have faster. I mean, with faster, at least you know what you're getting. Fastest, smart. Actually, this is not directly mapping. If we have fast and faster there, maybe. I mean, maybe I should just default to building smarter, not smartest, and leave that alone. But should we offer an optimization that we know can? I mean, especially given building a new whole distribution with T2, and then it's like known to be potentially unsafely broken. Yeah. Leave in the comments below. Or should we patch GCC, should we patch that away? Did I hit? Oh, here. Yeah, crazy times where live on YouTube you need to decipher such unsafe optimizations like that. Welcome everyone. Pedro asks how much is the impact percentage of multiple levels of Ofast? You mean O1, O2, O3? I had this benchmarked. I think Ofast was maybe, yeah, share, like and subscribe. Maybe I need to up here our efforts and also have a proper website with graphs to look this up in a more systematic manner. I would need to check my videos. That certainly is a problem of publishing videos. So basically, where do we have Ofast? I mean, yeah, so here was some huge outliner anyway. I mean, at times it was noticeably faster, right? It was, I think it at times was one of the more noticeable, at least potentially, if not. Yeah, 576. I mean, it is noticeable. What is 5? Was it 40 something here of 47, 76, 47. What, 67? No, what did I say? No, 76 actually. Yeah, I mean 6% is not, this is what other people overclock their freaking Ryzen CPU, right? The question is, the problem is I can't easily benchmark the impact of just removing this startup stuff alone. Maybe I should read this here in more detail. Where even was that? Did I? This like 6% is not too shabby to brush away. Maybe I should read this nice summary here carefully. Did I post it already? I think I posted it already, right? And determine which of them here are safe and potentially define like maybe the safest thing, or like the most, not safest, maybe the most useful thing would be if we patch our GCC, because this Ofast is, I would call maybe too dangerous to be generally usable, and change our patch GCC default. Actually, theoretically, we would need to check on LVM Clang what they do there, because some stuff is relatively okayish for very hot math code paths, maybe associative math, for vectorization stuff, and maybe create a safer fast default. The only thing is, if someone benchmark then Clear Linux versus our T2 Linux with Ofast, they might get better results, like better but unsafe, dangerous, and at times broken result. And then it would say on Phoronix, look, Clear Linux is faster than T2 Linux because it's fast with optimizing 2.5% faster. It's like here, optimizing unsafely. As it can affect code compiled without ffast-math, unsafe math optimizations. Yeah, I will review that. Maybe I will make a dedicated video. It probably doesn't make sense to live stream always for hours of my random research here. Anyway, there you have it. I hope you learned something. As always, don't forget to share, like, subscribe, and maybe, yeah, share, like, and subscribe, Patreon and GoFundMe and all the good stuff, because it would be amazing if, similar to others tech tips channel, we could afford here some more stuff and publish also what people always criticize, my hour-long video, make a freaking blog post. But the problem is with blog posts, I don't get money, right? The idea was funding open source and research, and with my otherwise blog post I earned next to nothing, was also partially broken because so I had some blog posts at times here and there, but as everyone knows, you can't earn money with it. So much to either you make a proper blog post that people can read and find and stuff, or you earn money like on YouTube. But yeah, the more you share, like and subscribe, and there we broke 10k subscribers on the more main channel, which if you didn't know we have that, is also amazing. So that would be cool if we could summarize that better. One last look there, useful to me, start learning. Working on development compiler, or should I focus on compilation and libc kernel diff? What do you mean it? ffast-math, not exactly. I always say focus on what you are most interested in. That's usually the most successful. One question there, it would fun. Mantham, weren't ffast-math toggles and like implemented game engines, faster software 3D? Yeah, but the problem is you can't really use it, right, for game engines when it's again, I would say this ffast-math, and which is also why I probably would want to patch that in T2 to be more useful. I would argue as it's not even useful for that, because then your game engine or other parts like here seen in even Red Hat Linux contaminating the rest of your program and degrading its math precision, which might be, so you can't like have a GL library with this CRT ffast-math linked in without clobbering all your science math stuff. Or it might even, like, imagine a game developer, right? They are developing AI movements or stuff, and then they link in some GL library or other Intel AMD driver, and then suddenly all their methods going wrong, and you get subtle AI or other bugs because all your math rounding stuff is often being rounded away, right? So I would agree with most experts that as it is way too dangerous to be useful for anything, probably, which might be a good reason to patch it in T2 by default, I guess, maybe. Anyway, Pedro says, so the loss of precision and increased performance may not compensate the loss of stability, accuracy. So there are multiple. So the math optimizations they're multiple, right? And so some of them actually might be useful. The main problem is that so there are like probably 10, 20 different of associative math and stuff, and some of the stuff is even useful as, or maybe even still like not standard conformance, but at least like some like math regrouping, association, and vectorization. The big problem is that it links in the startup like independently. So like, let's say if this are like, let's say it's 20 different fine-grained optimizations, maybe 18 or so are relatively okayish, not standard conformant, but potentially useful for 3D libraries or other math heavy code. But there are like one or two, like including this startup stuff. Like the major problem, to be specific, is the startup code that is changing the rounding mode in general for all the other parts of the program that were not optimized with that, right? That is a big problem. And so you can't even, as I said before, it would be much more useful if you can fine-grain ffast-math or fast some 3D or other math heavy parts without altering all your problems, right? So, and all the other 18 or so optimizations might actually be still useful, but due to that very dangerous, unsafe and unexpectedly harmful, that is altering due to touching the processor's floating point control word rounding mode. It is unexpectedly harmful, altering all your others code that otherwise would work fine, right? That is a truly dangerous thing, just to point this out. Probably why we want to change it. Also, one should say maybe instructions and architectures would be better defined to have actually instructions this global state in general not amazing. The problem is also that some or most processors have this global floating point control state. Probably most who have that here. I would need to check for RISC-V and stuff. And one could argue that it would be better if there would not be this global floating point rounding control word machine-specific register to control the rounding mode, but there were instructions, like you have the full featured instructions that are all the denormal, subnormal rounding and stuff, and you would have had like ffast-math instructions of not doing that. Then you could more, like without clobbering global state, which in general is very expensive. You can't even fast switch, right? Because writing and changing such stuff is highly expensive, especially in this wide out of order modern CPUs, which might need to have hundreds of instructions in flight. So you can't, like, this is also why changing such global control word, even others, not only that, but all of those is usually highly serializing because it has to flush all the in-flight instructions in all the reorder and buffers in the CPU to change such expensive global control word state. So on that, fine-grained instructions, as some also maybe in this article point out, might actually be vastly superior. But that's it now for this long video. I try to keep it shorter and more informative in the future. Hope you learned something, and see you next time for all the fun and unsafe and harmful and peak bugs to come.